I'm Barbara Rosario for ISSNAF Stories, and I'm with Filippo Menczer. Benvenuto.
Grazie, thank you.
So where to start? You are professor of informatics and computer science at Indiana University, Bloomington. You are director of the Observatory on Social Media, a member of the Center for Complex Networks and Systems Research, and you also have courtesy appointments in cognitive science and physics. So my first question is, how do you handle all this?
I work a little bit too much, and sometimes I don't sleep enough. But what I do is really exciting and interesting, and I have lots of wonderful students and collaborators. So all of the work that we do is really a collaboration, and that helps a lot, of course. And but yeah, it is a lot, but it is very interesting. So I'm excited to do it.
Tell us about the recent research project that you're excited about.
Sure. Well, in the last, I would say 12 years or so, my research has focused more and more on social media, and in particular, abuse and manipulation of social media. This involves, for example, misinformation and disinformation, the problems that are created by either people who on purpose manipulate social media to spread this disinformation, or also people who unwittingly spread it by sharing things that they believe may be true, but in fact are not, or maybe misleading. And also other kinds of manipulation, for example, coordinated campaigns and information operations. There are many examples of, for example, foreign actors that try to meddle in elections of some countries by impersonating certain people, or creating the appearance that there is a lot of support for certain ideas or certain people, or directly trying to interfere with elections, for example. The spread of misinformation about health can lead to real harm. For example, behaviors of people who choose not to be vaccinated, for example, during a pandemic, and that can lead to a lot of people dying. So there's lots of ways in which online networks, social networks, and social media can be manipulated. Most recently, we're focusing a lot on artificial intelligence, of course, especially generative AI, which provides powerful tools for bad actors to do these kinds of manipulation. And so we study the ways in which this manipulation can happen. We study methods and algorithms to detect this kind of manipulation by mining, sifting through large amounts of data about online behaviors and actions. We also model the behaviors of large numbers of users who interact online to understand what are their vulnerabilities, how these vulnerabilities can be exploited by bad actors, and how we can counteract these bad actions, how we can implement interventions that make people and networks less vulnerable to manipulation.
I read that your group developed tools for journalism that show what the online conversation is, the players are. What can you tell us about this? And also, is there anything in particular that was discovered thanks to these tools?
Oh, sure. I do like tools. I like it when the research that we do has some real impact in the real world. Part of that could be through policy, because we learn things that could help policymakers figure out how to prevent potential online abuse. But a lot of times we like to transform the algorithms that we develop, either for analysis or for visualization, or machine learning algorithms, in ways that they can be used by not just few expert researchers, but a broader public. And certainly journalists are an important audience for us. We collaborate very closely with the media school here at Indiana University. And so we try to develop tools that can help journalists understand how the information landscape can be manipulated, and how sometimes things that go viral are the result not of genuine interest or accuracy, but just to bad actors trying to manipulate the system in some way. So whenever we have some algorithm that could be used by a broader audience, we try to make it available online publicly. I can give you a few examples. Probably the most popular tool that we developed was called Botometer. It was a machine learning algorithm that looked at many different signals extracted from Twitter accounts and tried to come up with an assessment of whether a particular account was like a regular normal person using Twitter. The most simple example is fake accounts to make it look like people have more followers than they really have, or accounts that automatically retweet every tweet by some politicians, for example, to make it look like people are believing and engaged in this content. And our algorithm looked at many different signals. For example, how frequently an account is posting, or whether it looks like it's in one part of the world, but it's really probably posting from another part of the world, looking at the times of the day when they're posting, looking at the type of language that they're producing, whether they are creating text that doesn't look like real text generated by humans. And we look at the structure of this network and we see if it looks like the regular structure of social networks that we are engaged in, or whether it looks somewhat artificial. These are just some of examples. We had over 1,000 different features that the algorithm looked at, and then it came up with an estimate like, oh, it looks like maybe this is authentic or automated. This tool was used by lots and lots of people. It handles several hundreds of thousands of queries every day. It was used by researchers. It was used by journalists. It was used by people, common users of social media. Another tool that we developed is called Hoaxy, and is meant to visualize the networks of interactions that occur on social media, like Twitter, for example. So it visualizes who's resharing information from whom, who's mentioning whom, who's retweeting whom. And in this way, we can identify what are the communities that are contributing to the spread of a piece of information, and also who are the most important accounts, who are the most important actors, maybe the most influential ones, the hubs. And we have a few other visualization tools like that. Some that show trends in the use of certain keywords or certain hashtags. We have some tools that are based on models, where people can play with different scenarios and see what happens. For example, we have a tool that helps people appreciate how echo chambers, online echo chambers, can emerge. Echo chambers are groups and communities of social media users that are very similar to each other, so that you are only connected to people who have similar opinions or ideas to yours. And so basically what you hear, what you see, is an echo of your own opinions. They tend to be insular. They tend to be disconnected from other groups, and then within these groups, these echo chambers, opinions tend to be very polarized around a particular homogeneous set of ideas. So many people believe that the existence of these echo chambers are not healthy for our information exchange, because people are not exposed to other ideas, and we have studied how basic mechanisms of social media lead to the emergence of these echo chambers. So if somebody posts something that you find very offensive, you might disconnect from them and say, I don't want to follow this person anymore. You might follow somebody else. People don't want to be in echo chambers, but just by selectively unfollowing people that they disagree with, they will even inevitably end up in these echo chambers. So this is a tool. We have a tool called Echo Demo, which is a demo of how these echo chambers emerge, and people can play with different parameters and see what are the outcomes, how quickly you end up in one of two or more echo chambers, and how opinions tend to become very homogeneous, and how different groups become segregated.
I read that you also work on the science of science. So what's that? And can you summarize your research in this area?
Sure. Yeah, this is another area of interest for me. I would say that, my interests are broadly in information networks. So social networks and social media are one kind of information network, but science itself is represented by information networks. When we write papers with other scientists, and we collaborate with our co-authors, and that's a kind of social network. Furthermore, when we write a paper, we have to cite other relevant papers, other relevant work that was done prior that has influenced our own work. And so if you look at the network of citations and references between papers, there is a lot of important information in these networks that looks at how ideas propagate from one person to another, from one paper to another, and how they become impactful. Looking at how many times a particular paper is cited is one way to measure its impact within the scientific community. So science of science is basically the science that studies all the data in which science is produced and propagated and diffused from person to person, from scientist to scientist, from community to community, from a university to another, and how it gets translated into practical applications through patents and products and the impact that it has. And we understand what are the patterns that drive the dynamics of science. Why do scientists flock to certain problems? Or why do they migrate from one discipline to another? How do productive collaborations and teams emerge? And how do you measure the productivity or the impact of different patterns of collaborations? Can we predict, in some sense, the future of science?
You were recently nominated member of the Scientific Council of ISSNAF. What would you like to achieve in such a role?
Well, I'm Italian, of course. I was born and raised in Italy, and I went to the United States for graduate school, and I have lived in the United States, for many years. I still interact somewhat with colleagues in Italy, and usually that interaction is very good. And when we are lucky enough to have some students from Italy in our lab, whether graduate students or postdocs, they are excellent. So Italy is producing amazing intellectual capital. So this, for me, is an opportunity to give back a little bit and to help foster these interactions and to support especially young scholars from Italy who are end up interacting with the science community in the United States. Of course, by having these strong interactions and collaborations, I think is going to be good for science. So this is just a way for me to help that process in the little way that I can.
You mentioned that you have some professional connections with Italy.
Right now, we are collaborating in particular with colleagues at the Polytechnic University of Milano on various projects related to health misinformation and the study of information diffusion in new platforms. We have some visiting scholars from Italy that are working on very interesting problems related to different kinds of networks. For example, networks of voting where people express their opinions, or whether people participate in polls, or whether people provide ratings, for example. So we have a visiting scholar working on those problems.
Where and what did you study?
I studied physics originally for my undergraduate. I got my laurea at the University of Rome, La Sapienza. I did my laurea in an interdisciplinary area that spanned physics and cognitive science. I was very interested in networks, especially neural networks. I studied with Professor Domenico Parisi. He was a very well-known psychologist and cognitive scientist, and collaborated with Professor Virasoro, who was a very well-known physicist. So I was lucky that already at that time I was doing interdisciplinary work that spanned physics and cognitive science and artificial intelligence. And then after that, I wanted to learn more about the computational aspects of this work, the algorithmic aspect. So I wanted to do a PhD in computer science. And at that time, there weren't so many opportunities, so many people working in this particular area of complex systems from a computational perspective in Italy. And so I went to the United States and I did my PhD at the University of California, San Diego.
What do you like the most about living in Indiana?
I work at Indiana University Bloomington, which is the main campus of Indiana University. And Bloomington is a small college town. And it's a very good place, to live. Life is relatively easy. It's not a huge metropolis. It's easy to get around. But at the same time, because it's a large campus, we have almost 50,000 students. It's a big university in a relatively small town, but that means that there's a lot of young people. It's a very young town. It's a very young city to live, with lots of exciting things, with great music. There's an amazing school of music here, with good food and museums and art, and there's lots of fun things to do, even for a small town. Bloomington it's a beautiful place. It has a lot of green and lots of opportunities for sports, and so life is relatively easy, and it's good to get a lot of work done.
What piece of advice would you offer young Italian researcher in your field coming to North America?
I would say that if they are coming to the United States, they should, of course, look at where interesting research that is relevant to their interests is happening. I think that there is a very natural tendency for young people, and for everybody actually, to pay attention to the top-ranked universities. And of course, there are some real reasons why those universities are top-ranked. But there is also a very natural tendency of, rich get richer dynamics. This is well-studied dynamics in areas like those that we study in networks, where there is a node in the network that gets more attention, more funding, and just because it gets more attention and more funding, it attracts more attention and more funding. So I think that if you look at the difference in impact and quality across different universities, you will see that that difference is much smaller than the difference in attention that they received. So what this means is that there are many universities who are not so well known as the Stanford and the Harvard and the MIT and so on, but where there is a lot of very good people doing interesting work. So I hope that students keep an open mind and really look at where the good work is being done, just rather than just universities that they recognize the name or because they are very famous or popular. And there are a lot of good people working in many different universities, whether it's on the East Coast or West Coast, but also in other parts of the countries in the Midwest. So there is a lot of good quality work and great researchers everywhere. So you have to cast a wide net.
And do your homework.
And do your homework, for sure, for sure.
Grazie mille, Phil.
Prego, veramente un mio piacere. Grazie, Barbara.